Technically, the power company, or POCO, has the right to mandate a mast. The National Electrical Code, NEC, and most utility company policies require that service drops over roofs be elevated at least 8 feet above the roof. This is a safety measure to prevent accidental contact with live wires. However, our residents may be grandfathered in, meaning that the existing installation was compliant with the code when it was initially installed, even if it does not meet current code requirements. In some jurisdictions, grandfathered installations are allowed to remain as long as they continue to function safely. Other similar installations in the area may not necessarily be considered grandfathered in. If the installations were not compliant with code when they were originally installed, they may be subject to correction. However, the POCO may be more lenient in enforcing code violations for older installations. It is unlikely that other residences will be subjected to the same installation criteria if they are not causing a safety hazard. The POCO is more likely to focus on addressing the more serious safety concerns first. The homeowner could consider installing a mast to comply with the POCO's request and improve the safety of their electrical system. This would also help prevent future issues with the POCO. Alternatively, the homeowner could negotiate with the POCO to keep the existing installation as long as it continues to function safely. This may involve having the installation inspected by a qualified electrician and providing documentation to the POCO. Consider the NEC requirements for service drops and clearances. The NEC specifies minimum clearances for overhead service conductors to ensure safety and prevent accidental contact. These clearances vary depending on the voltage of the conductors and the location of the conductors relative to buildings, ground, and other objects. Article 230 of the NEC covers service entrances, and it provides detailed requirements for service conductors, service equipment, and overcurrent protection. It addresses the installation of service masts, including their height, strength, and support requirements. Understanding these requirements is crucial for ensuring a safe and compliant electrical installation. The NEC also addresses the concept of existing installations and alterations. Generally, existing electrical installations are allowed to remain in place as long as they are safe and continue to meet the code requirements that were in effect at the time of installation. However, if an existing installation is altered or extended, the altered or extended portion must comply with the current edition of the NEC. This means that if a homeowner modifies the service entrance, they may be required to bring the entire installation up to current code standards, including installing a service mast if required. Utility company policies often supplement the NEC requirements. Utility companies may have their own specific requirements for service entrances, metering equipment, and other aspects of the electrical system. These requirements may be more stringent than the NEC requirements in some cases. It is important to consult with the local utility company to determine their specific requirements for service installations. The grandfathering clause, as it's commonly referred to, provides a level of flexibility for existing installations. The intent is to avoid forcing homeowners to upgrade their entire electrical systems simply because the code has changed. However, the grandfathering clause does not apply if the existing installation is unsafe or poses a hazard. In such cases, the authority having jurisdiction, BOJ, which could be the local building inspector or the utility company, has the authority to require the homeowner to correct the unsafe condition. When evaluating whether an existing installation is grandfathered, it is important to consider the original code requirements that were in effect at the time of installation. These requirements may be different from the current code requirements. For example, the required clearance for overhead service conductors may have been lower in the past than it is today. If the existing installation met the code requirements at the time of installation, it may be considered grandfathered, even if it does not meet current code requirements. However, if the existing installation never met the code requirements, it is not grandfathered and must be brought up to code. If there are similar installations in the area, the POCO may take a consistent approach to enforcing code violations. However, the POCO may also prioritize addressing the most serious safety concerns first. For example, if an installation poses an immediate threat to public safety, the POCO is more likely to require the homeowner to correct the condition promptly. The homeowner has several options to consider. Firstly, the homeowner can install a service mast to comply with the POCO's request. This is the more straightforward way to ensure compliance with current code requirements and utility company policies. A qualified electrician can install a service mast and ensure that it meets all applicable requirements. Secondly, the homeowner can negotiate with the POCO to keep the existing installation as long as it continues to function safely. This may involve having the installation inspected by a qualified electrician and providing documentation to the POCO demonstrating that the installation is safe. The homeowner may also be able to obtain a waiver from the POCO allowing the existing installation to remain in place. Thirdly, the homeowner could appeal the POCO's decision to require a service mast. The homeowner can submit a written appeal to the POCO explaining why they believe the existing installation is safe and should be allowed to remain in place. The POCO will typically review the appeal and make a decision based on the specific circumstances of the case. When negotiating with the POCO, it is helpful to have documentation to support the homeowner's position. This documentation may include photographs of the existing installation, a report from a qualified electrician, and copies of the original code requirements that were in effect at the time of installation. It is also helpful to be polite and respectful when communicating with the POCO. Building a good relationship with the POCO can increase the chances of reaching a mutually agreeable solution. Consider the potential costs and benefits of installing a service mast. Installing a service mast will involve some expense, including the cost of the mast, the cost of labor, and the cost of any necessary permits. However, installing a service mast can also provide several benefits, including improved safety, reduced risk of future problems with the POCO, and increased property value. Before making a decision, it is important to weigh the costs and benefits carefully. When hiring an electrician to install a service mast, it is important to choose a qualified and experienced electrician. The electrician should be licensed and insured, and they should have experience installing service masts. The electrician should also be familiar with the NEC requirements and the local utility company policies. Be sure to get a written estimate from the electrician before starting the work. The estimate should include a detailed breakdown of the costs, including the cost of materials, the cost of labor, and the cost of any necessary permits. It is also important to get a warranty on the work. The warranty should cover both materials and labor. The homeowner should also consider the potential liability for any accidents or injuries that may occur as a result of the electrical installation. If the homeowner performs the work themselves, they may be held liable for any accidents or injuries that occur. If the homeowner hires an electrician, the electrician may be held liable for any accidents or injuries that occur. It is important to have adequate insurance coverage to protect against potential liability. The NEC is updated every 3 years, so it is important to stay up to date on the latest requirements. The NEC is available for purchase from the National Fire Protection Association, NFPA, and other sources. Many local libraries also have copies of the NEC available for reference. The local building department can provide information on the specific code requirements that are in effect in the area. The building department can also provide information on the permit requirements for electrical work. Consider the potential impact of the electrical installation on the environment. Electrical installations can have an impact on the environment, including the consumption of energy and the generation of waste. It is important to take steps to minimize the environmental impact of electrical installations. This can include using energy-efficient equipment, recycling materials, and properly disposing of waste. The homeowner should also consider the potential for electrical hazards such as electric shock and fire. Electrical hazards can be caused by faulty wiring, damaged equipment, and improper use of electricity. It is important to take steps to prevent electrical hazards. This can include having the electrical system inspected regularly, repairing any damaged equipment promptly, and using electricity safely. If you are unsure about any aspect of electrical safety, consult with a qualified electrician. They can provide you with advice and guidance on how to stay safe around electricity. Keep electrical equipment away from water. Water is a good conductor of electricity, so it can create a path for electricity to flow through your body. Never touch electrical equipment with wet hands. Do not use electrical appliances near bathtubs, showers, or swimming pools. If an electrical appliance falls into water, do not reach in to grab it. Instead, turn off the power at the circuit breaker or fuse box. Do not overload electrical outlets or circuits. Overloading can cause the wires to overheat and start a fire. Use power strips with surge protection to protect your electronic devices from power surges. Inspect electrical cords and plugs regularly for damage. Replace any damaged cords or plugs immediately. Do not run electrical cords under rugs or furniture. This can cause the cords to overheat and start a fire. Use ground fault circuit interrupters, GFCIs, in areas where there is a risk of water exposure, such as bathrooms, kitchens, and outdoor areas. GFCIs are designed to protect you from electric shock by quickly shutting off the power if a ground fault is detected. If you smell burning plastic or see sparks coming from an electrical outlet, turn off the power at the circuit breaker or fuse box and call a qualified electrician. Do not attempt to repair electrical equipment yourself unless you are a qualified electrician. Electricity can be dangerous, and it is important to take precautions to protect yourself from electric shock and fire. The NEC provides requirements for grounding and bonding of electrical systems. Grounding and bonding are essential for protecting people from electric shock and for preventing fires. Grounding provides a path for fault current to flow back to the source, which causes the circuit breaker or fuse to trip, shutting off the power to the circuit. Bonding connects all metal parts of the electrical system together to create a low impedance path for fault current. This helps to ensure that the circuit breaker or fuse will trip quickly in the event of a fault. Article 250 of the NEC covers grounding and bonding requirements. It provides detailed information on the types of grounding systems, the methods of grounding, and the requirements for bonding. The NEC also provides requirements for overcurrent protection. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect electrical circuits from overloads and short circuits. Overloads occur when the current in a circuit exceeds the ampacity of the wires. Short circuits occur when there is a direct connection between two ungrounded conductors. Overcurrent protection devices trip or blow when the current exceeds a certain level, shutting off the power to the circuit. Article 240 of the NEC covers overcurrent protection requirements. It provides detailed information on the types of overcurrent protection devices, the selection of overcurrent protection devices, and the installation of overcurrent protection devices. Consider the requirements for wiring methods. The NEC specifies the types of wiring methods that are permitted for use in different locations. Wiring methods include conduit, cable, and raceway. The type of wiring method that is used depends on the application, the environment, and the code requirements. Article 300 of the NEC covers wiring methods. It provides detailed information on the types of wiring methods, the installation of wiring methods, and the requirements for supporting and protecting wiring methods. The NEC also provides requirements for equipment installation. The NEC specifies the requirements for installing electrical equipment such as receptacles, switches, lighting fixtures, and appliances. The requirements for equipment installation are designed to ensure that the equipment is installed safely and correctly. Article 400 of the NEC covers equipment for general use. It provides detailed information on the installation of various types of electrical equipment. And always remember that local codes will always supersede national codes.